Hello students, in the previous videos we have seen the preparation and manufacture of ammonia. Now we will study the properties of ammonia in this video. Keep watching. Properties of ammonia. Ammonia, as we know, is a colorless gas. It has no color and it has a very characteristic pungent odor. The odor is there, very irritating. If you breathe, it will give you a coughing sensation. And then it is a non-poisonous gas. Why do we say non-poisonous? Because it does not react with blood. The gas that does not react with blood is called non-poisonous, but it is toxic because it can cause harm. Even though it does not react with blood, it can cause a lot of harm to our body, and it affects the respiratory system. So it will prevent or choke the system, and therefore the person cannot breathe air, and respiration process will stop. So it can be fatal in large doses. Fatal means the person can die if he breathes excess of ammonia. And next thing is, ammonia is lighter than air. It has a density. The density, how do you know density? Ammonia, NH3. Nitrogen atomic weight is 14 plus hydrogen, 3 hydrogens, 3 into atomic weight of hydrogen is 1 is equal to 17 is the molecular mass. So molecular mass upon 2 is equal to density. Okay, that's how you take. That's equal to 8.5. Air has a density of 14.4. So ammonia is lighter as it is 8.5, right? Because of this reason, if you have a jar of ammonia and a jar of air inverted over it, what happens is ammonia moves up and air comes down. It can be easily liquefied by cooling under pressure. So liquid ammonia can be obtained. It is possible to get liquid ammonia by cooling under pressure and store in steel cylinders, and this way it can be transported. So ammonia is transported in the form of liquid, not in the form of gas, right? Because it will enable us to carry large quantities in small space. It is highly soluble in water. 702 volumes of ammonia dissolves in 1 volume of water. So it is a very high solubility, and when it dissolves it will produce NH4OH, ammonium hydroxide is produced. Now there is an experiment called the fountain experiment which will show the high solubility of ammonia in water. So it is a very interesting and fascinating experiment. What you have to take is a dry flask. The flask is dry, okay, and you fill dry ammonia inside. Again ammonia gas which is also dry, there is no moisture, and it is closed with a cork having 2 holes. There is a jet tube inserted through one hole. Jet tube means the tip is very narrow. The tip of the tube is narrow and there is a narrow opening, okay, that is jet. And the other end is dipped in a solution. This is a red litmus solution. You can take water also, but red litmus means it will give some color. Red litmus solution, red litmus dissolved in water. And the other hole is having a the ink dropper. An ink dropper filled with water is kept here. So the whole thing is set up. It should be airtight. What happens is, the moment you press the dropper, what happens? A few drops of water comes into the flask. Now you'll be surprised to know these few drops of water is sufficient to dissolve the entire gas inside. So what happens is, the gas will dissolve, so it will cause vacuum in the flask. Because the gas gets dissolved rapidly, vacuum is created. Now since atmospheric pressure is acting on the surface of this water, that is red litmus solution, the red litmus solution rises inside the jet and comes out as fountain. The moment it comes out, the color changes to blue because ammonia is a basic gas, alkaline gas. So this beautiful experiment will demonstrate that ammonia is highly soluble in water. It also shows that ammonia is alkaline as red litmus turns blue. So what does the fountain experiment demonstrate? If a question is asked, it shows that ammonia is highly soluble in water and also it is alkaline in nature. So these are the important things. So the fountain experiment. Name the experiment which shows the high solubility of ammonia in water. The name of the experiment is fountain experiment. What does it demonstrate? It demonstrates the high solubility of ammonia in water. You must write it completely. Don't write half answers, okay? Write it fully. Then it also demonstrates that ammonia is alkaline if we use red litmus. If we use water here, there will be no color change. The fountain will still form, but there will be no color change. So you cannot show alkaline property. The next property is ammonia is a non-combustible and non-supporter of combustion. What do you mean by non-combustible? Non-combustible means it does not burn in air. Okay, so it will not burn in air. Now the non-supporter of combustion means it does not allow other things to burn in its presence. If ammonia is there, it will not allow other substances to burn. So non-supporter and non-combustible. Okay, so I think this is clear. Now the next thing to note is ammonia burns in an atmosphere of oxygen. See, just now we said it is non-combustible. It does not burn in air, but it will burn in an atmosphere of oxygen. The air contains only, air has only 20% oxygen. But when you say atmosphere of oxygen, it is 100% oxygen. That is the difference. You have to understand. It's a non-combustible gas, but if 100% oxygen is given, it can burn. So it will produce nitrogen and water vapor. So you can write the reaction. NH3 plus O2 will give N2 plus H2O, NH3. So 2 nitrogen. So we take 4 NH3, 2 N2. So 4 3 is 12. So 6 H2O, 6 oxygens, 3 O2. Okay, so this is how you balance it. So ammonia reacts with oxygen. It burns. Now there is a pale green flame. Pale green flame. See in color of the flame also. You can see the diagram. See the diagram here. So oxygen gas is supplied here. Ammonia is also supplied. Cotton layer is kept there. So they mix, and at the tip of the jet tube or the tube, glass tube where ammonia is coming, it is burning. A green flame, greenish yellow or a pale green flame is produced. So this is a reaction where ammonia burns to give nitrogen, but it does not burn in air. It burns only when 100% oxygen is supplied. Air is not supplied here, oxygen is supplied. Remember that. Okay, right. Now the next is ammonia undergoes catalytic oxidation, means it can be oxidized in the presence of a catalyst. A mixture of ammonia and air or oxygen, either air or oxygen, is passed over heated platinum catalyst. Catalyst is there, platinum. It gets oxidized to nitric oxide and water vapor. Let us see the experimental setup where this happens. See the diagram here. The dry oxygen is supplied here and dry ammonia. You may also supply air instead of oxygen here. Now it is passed over heated platinum. Here we have platinum metal which is acting as the catalyst. It will provide surface where the gases can adhere, and then they come in contact and react. So produces, see, the nitric oxide and water vapor. So the reaction, we can write the reaction. What is the reaction? Ammonia NH3 plus O2. Even if you supply air, only oxygen reacts. Platinum catalyst is present. Temperature is 700 to 800 degrees Celsius. You get NO plus water. NO is nitric oxide. Nitric oxide, or you may call it as nitrogen monoxide. Nitrogen monoxide. Okay, so how do you balance this? 3 4 4 6 H2 and 5. Okay, yeah, so it is balanced. So you get nitric oxide and water vapor. The nitric oxide can combine with air to form nitrogen dioxide, which is reddish brown. Nitric oxide is colorless, whereas nitrogen dioxide can be reddish brown. So colorless nitric oxide changes to reddish brown nitrogen dioxide when the gas mixes with air. So you get nitrogen dioxide. This is one reaction. The next is ammonia is basic in nature. Basic means it can react with acid to give salt and water. It turns red litmus to blue, moist red litmus to blue. NH3 plus water will give NH4OH, ammonium hydroxide, which will dissociate as NH4 plus ions and OH minus ions. So OH minus ions are produced, so it is alkaline. Since it is alkaline or basic, it reacts with acids to give salts. NH3 gas, ammonia gas and hydrogen chloride gas mixed together will form NH4Cl, which will be dense white fumes. Dense white fumes. If you take ammonia gas and pass through aqueous hydrochloric acid, hydrogen chloride solution, here you get NH4Cl solution. NH4Cl in the aqueous form. Okay. So salt is produced. Then again ammonia reacts with nitric acid. Nitric acid, it will give NH4NO3. Okay, ammonium nitrate. This is ammonium nitrate. And what is this? This is ammonium chloride. Salt of the acid. Hydrochloric acid will give chloride, nitric acid will give nitrate. So we also have sulfuric acid. Ammonia reacts with the next important acid is sulfuric acid. It will give ammonium sulfate, NH4 whole twice SO4. Ammonium sulfate. Now 2 NH3 is required. So NH4 whole twice SO4. Now the next thing, these are salts produced. Next is, it is a reducing agent. Ammonia can reduce metal oxides to metal. Example, it can reduce copper oxide. Copper oxide plus ammonia, it will give metal, copper metal plus nitrogen plus water. 3 products are formed. So you can take 2 NH3, 3 H2O, 3 Cu and 3. Okay, so it is balanced. Same way we can have lead monoxide, PbO. PbO plus NH3. So will give Pb plus N2 plus H2O. Right? So 3 N2, 3 Pb, and you have N2 plus 3 H2O. Okay. So this way it is balanced. So metal is produced. The metal oxide changes to metal. Copper oxide changes to copper. Lead monoxide to lead, along with nitrogen and water vapor. You see the apparatus setup. The hard glass tube is there where you have the metal oxide present, copper oxide, example, black color substance. Dry ammonia is passed, it is heated. So water vapor is collected here and the metal will change to pinkish particle. Example, this is black. Now this is an observation that you can write. Black powder will give you, the copper formed will be pinkish deposit. Pinkish deposit. Okay, so pinkish deposit of copper particles will be produced. Now lead monoxide is pale yellow. It is pale yellow. It will change to grayish white metal. So these observations are there. Right. Ammonia also reduces chlorine, reacts with chlorine. 2 types of reaction depending on concentration. When ammonia is in excess and chlorine is less, the reaction will be NH3 plus Cl2 will give ammonium chloride, NH4Cl plus N2. This will be produced. Ammonium chloride is there, so dense white fumes will come. So you can write it as 6 and 8. Yes, and N2. So 3Cl2. So this way you get ammonium chloride, which is dense white fumes. Now if you take excess of chlorine, chlorine is in excess, ammonia is less. In this case, NH3 plus Cl2 will give NCl3, nitrogen trichloride and hydrogen chloride. So here you have 3Cl2 and 3HCl. So nitrogen trichloride, this is nitrogen trichloride, which is a yellow colored explosive liquid, right? The observation is yellow colored explosive liquid. Ammonia colorless, chlorine greenish yellow gas, yellow colored nitrogen trichloride, which is an explosive liquid. Okay, so that is all about the properties of ammonia. So students, I suppose you understood the properties of ammonia. So you can keep writing this again and again, watch the video again, and you may send your queries and comments. Thank you.